tell me something that is unique to a linear pattern or an arithmetic pattern, some way that we can identify them. How do I know I'm working with a linear pattern? And again, feel free to just unmute, absolutely fine, or you can type it in the chat. How do we identify what a linear pattern is? How do I know a pattern's linear? Another way to think about the question is, what makes a linear pattern unique? What is its defining characteristic? Anyone? Very so nice. Okay, so guys, in terms of our constant differences, we've already spoken about quadratic patterns and the fact that those have constant second differences. If you want to differentiate the two, you could say that linear patterns have constant first differences. But obviously, if there's a constant first difference, there can't be a second difference because that would just be zero. So you can say constant first difference or constant difference. That's absolutely fine. As long as you understand that in your head, it's the first differences that you find that will be constant. And again, like we saw on Monday with the quadratic patterns, this is a feature that we need to know because we're going to be able to use it to solve for unknowns in patterns as we move along and as we start to deal with slightly complex questions. All right, as the name also sort of gives away, if we were to graph this out, or if we were to imagine a visual representation of arithmetic or linear sequences, it would be linear. And this goes back to that constant first difference. If you're adding the same thing each time, if you were to draw a graph, it would be a perfectly straight line. If you were subtracting the same value each time, again, it would be a straight line. Now, you don't have to stress about needing to draw graphs in this section, but it is important to start to link the fact that we have done linear concepts or linear equations in multiple different sections. Equations, functions, now in number patterns, these come up a lot, and it's important to sort of link all of them because they all relate to and rely on each other. All right, but very basically, exactly as Borisov said, it is a constant first difference. If we have that, we have got a linear pattern. So let's have a look at our first example here. Okay. So we have got the arithmetic sequence. And again, guys, generally we do tell you the arithmetic sequence, the geometric sequence, etc., etc. If we don't, you will need to go and figure out, is there a first difference? Is there a common ratio, etc., to figure out what pattern you're working with. But 9 times out of 10, we tell you what it is. You don't have to guess. Okay, so we've got the arithmetic sequence 5, 12, 19. And we do have 3 questions here. You can only see 2 of them, but we've got some questions. So exactly like I said on Monday, first, just figure out what's going on in your pattern, because all of that information is going to help you answer the questions that follow. So the first thing that we see here is that it is arithmetic because each time I'm adding 7 to get my next term. Because I'm adding the same number or the same value each time, it's linear or arithmetic, whichever one you want to go with. And so we know what we're working with. So we want to find the general term, and you guys told me on Monday that the general term is like the rule that we use to find any term in our sequence. But does anyone know, or can anyone tell me what is the general rule of a linear or arithmetic sequence? What is the formula that we use? There are actually 2 formulas that we can use, and it really doesn't matter which one you do use. Anyone remember? You start to use this from about grade 9. Nice, Katlego, very nice. It is exactly that. So one of the formulas we can use is Tn is equal to A plus N minus 1D. One of the other formulas that we can use, and I don't know how often people use it, is Tn is equal to Dn plus C. I'll do both just so that you can see how you would approach both of them. Excuse me. And then you can decide what you want to use. Some teachers I know do prefer you use the one in green, so the Tn equals A plus N minus 1D. I personally, it makes no difference to me. And when it comes to finals, both of them are going to be marked right. So it is up to you, but obviously if your teacher is quite strict about what you can and can't use, go with one you're comfortable with. But I will show you both just so that you can see both work, and then you can decide what you want to do. All right, so let's just quickly understand what each of these formulas are telling us, because obviously to use a formula, we have to know what the variables represent. So can anyone tell me what A represents? What value does A represent?
It represents the first term.
Nice, Katlego. First term. Right, so this is your first term of your sequence. In this case, our first term is 5. D, what does D represent?
D is the constant difference.
Nice, okay, nice, Katlego. D is our constant difference. So as long as we've got those two things, we are able, spot difference there. We are able to find our formula. So we need the first term and we need the constant difference, and then we're sorted. N is still the position of your term. So the first, second, third, fourth, fifth, etc., etc. Tn is still your term value. So that doesn't change from what we spoke about on Monday with the quadratics. It's still the same. But A and D are new here because we're working with a new type of pattern. Right, I'll deal with the blue in a second. Let's just carry on with this idea over here. So if we're going to go and find our general term, we essentially just substitute in the information that we have. So like I say, 5 is your first term. You're finding a general term, guys. So you're not going to substitute in a value for n because you're not finding a specific term value. You are just looking for a general formula that will give you the value of any term. And then we are multiplying that by our difference, which we've already worked out, is 7. Okay, now, technically speaking, we should always simplify what we have, but just to let you know, if you don't simplify, once again, you're not going to be marked down in finals. So when it comes to finals, if you leave your answer as it is without simplifying, you won't be marked down. Personally, I always just like to simplify. That's just personal preference. But you won't be marked down if you leave it like this. I am going to simplify though, it just makes more sense in my head. So that means I need to distribute the 7 into my bracket, giving me 5 plus 7n minus 7. And so Tn is equal to 7n minus 2. Right, so quite nice and easy. Like I say, you've been doing these since grade 8, grade 9. It shouldn't be anything too new. What might be new is the blue formula that I have here. Now, just so that we know, again, Tn and n represent the same thing as usual. It is still n your term position and t in your term value. But now d is representing your, let's not say first, let's say constant, your constant difference. And C, if you think back to what I was saying earlier, this is like a straight line. C represents that constant term. So if you think back to y equals mx plus c, C is that constant term that we add or subtract at the end. Graphically, that would be our y-intercept. But here, this is just a constant term that we would add or subtract in order to make our equation or our general term true. So if you want to use the blue, which again, is completely up to you which one you decide or which one you prefer. We can substitute in our value of d because we know that that is 7. We've worked that out. But we do need to work out the value of c. So this formula is a bit different from the general formula that we saw in green because you need to know term values. Now, whichever term you pick, it's going to work because the rule applies to any term. So if, for example, I pick this term 5, we know that term 1 has a value of 5, and so we know what Tn is and we know what n is. So we could substitute into our formula in order to solve for C. So this would be 5 is equal to 7 times 1 plus C. And in solving for C, we get C is equal to -2. And so Tn is equal to 7n minus 2. As you can see, you get exactly the same answer. So that's what I'm saying. It doesn't matter which one you choose. It's completely up to you. You decide what makes sense. You could also do this by inspection. As you can see, there is a relationship between your coefficient of n and your first difference or your constant difference. The coefficient of n is always the number you add or subtract. So if you know that, you've got the n term, and then you just work out what needs to be added or subtracted. So there's lots of different ways you can work out the general term. You just decide which one works best for you. If a formula works best for you, that's what you use. Okay, there's no prescriptive, you have to use this method, you decide. Right, so there's a fair amount of information, grade 12. So are we all okay? Does anyone have any questions? Otherwise, we're going to have a look at the next one, and then you are going to try some by yourselves. Cool, thanks. Right, so let's have a look at the second question. So the second question is asking us to determine the 10th term of the sequence. Now remember, that is a position. So which variable am I being given there? Have I been given Tn or have I been given n? Nice idea. Right, guys, this is n. It is the position. All right. Remember, position, as we wrote here in the green, represented by n. Because we have our general formula, that's just a substitution. So term 10, or the value of term 10, is equal to 7 times 10 minus 2, which means that our term 10 value is 68, because 7 times 10 is 70, minus 2, 68. So remember I said on Monday, these sorts of questions are definitely the easier questions because it's a straightforward substitution solve. You're not trying to manipulate and solve for an unknown value because everything on the right-hand side is then known once you've substituted. It's quite literally just putting it into your calculator and solving. Questions like question C, which I'm just going to move up a bit, are a little harder because it does involve solving an equation. But remember, this is a linear pattern. So you're solving a linear equation, which is a lot easier. So again, I'm just going to write our formula down here for us. If we now look at question C, I'm asking which term in the sequence has a value of 187. So again, my question, have I given you n or have I given you Tn? Nice, Morgan. Exactly, guys. I've now been given the value of Tn. I've been given a value of a term. So I would substitute that in. 187 is equal to 7n minus 2. And the question asks which term. So this is asking for a position. And as we just discussed, position is represented by n. So we're going to solve for n. Like I said, it's a linear equation, so it is a little easier. 189 is equal to 7n. To solve for n, we would divide both sides by 7. And if I'm not mistaken, 189 divided by 7 is 27. You can disagree with me, but I'm fairly certain 189 divided by 7 is 27. Now, remember, you do not have to go and say, therefore, the value of the 180, sorry, the value of the 27th term is 187. That's not necessary. You telling me n equals 27 is answering the question. So there's no need to write out a sentence. Obviously, if you feel that way, you can, but we try and save as much time as we can. All right, so I'm just going to make that a touch smaller in case you want a screenshot. Does anyone have any questions about this first example? Right, I'm going to give you ones to try now. We're going to do it the same as Monday. There's a slightly easier one if you're not feeling super comfortable. And then there's a slightly harder one if you feel like, cool, I understand linear equations. I can challenge myself a little bit. You decide which one you want to do. If you want to do both, that's cool. What I will do though is I will obviously show the answers to both, and then you can screenshot, and then at least you've got a question to practice if you would like. All right, but I don't see any questions, which is awesome. So these are your two questions you can try. Like I said, decide which one you want to go for. Either you want the slightly easier one or the slightly harder one. It is entirely up to you which you choose. I'm going to give you 5 minutes to pick the question you want to do and answer it. We'll have a look at the answers and then we'll move on. Righty, but guys, like I was saying on Monday, this is the section where you can bank your marks. So it's really important when I do put examples up like this, where I say, try it, you do. This goes back to what we were talking about on Monday. We need to work independently. We need to make the mistakes to figure out where we're going wrong or where we may be struggling a little bit so that we know where we need to work. Alrighty, but I will start talking now and give you guys quiet to work on these. Obviously, if you've got questions, unmute yourself and ask, or put it in the chat and I'll help you. But you decide which one are you going to do. Guys, do we need a bit more time? Or are you ready for answers? You can just give me a thumbs up or thumbs down. Happy to give you more time. I did say 5 minutes. Cool, no problem. A little bit more time. Okay, guys, let's have a look. Remember, if you don't or aren't finished, don't stress. I will give you time to take a screenshot. So if you did the slightly easier one, it was an increasing pattern. We were adding 3 each time. So you could work out what your first difference was, and then you could go and work out what the general term and then the 50th term was. Remember, once you've got that rule, life becomes easy, right? You have got the ability to essentially determine values, positions. We can start getting more complex with it and adding on to it, but that rule is so, so important. Question B asks which term will be equal to 74. Because I'm telling you the value of the term, I'm giving you Tn. It would also help if I use 74 here. Panic. Right, so 74. So this works now. Did anyone pick up this issue? I don't know if anyone did the easy one. It should have said 73 there. I do apologize. I went through this clearly with nothing happening in my brain. Sorry, guys. That's corrected now. But there you go. If you ran into an issue, the issue you would have run into is your end value is a decimal. Okay. And we spoke about this on Monday. Your end value can't be a decimal. It has to be a natural number. Alrighty. Question medium. Sounds a bit odd, but anyways. The medium question, if this is the one you chose. This was now a decreasing pattern, but still linear. We were just subtracting a value each time. Same thing. Get your rule. Once you have that, you can pretty much determine anything. And then I asked you which term had a value of negative 853. And so substitute and you can solve for n. All right, so really, like I say, as long as you've got that formula, there's a lot of things that you can do. Obviously, we can start to make things a little harder. and that is just generally how maths is. But the basic stuff, if you can find that formula, if you can work out your first difference, you are golden. Okay, so I'll leave that there in case you want to take a screenshot. Sorry about that, question B. I did actually mean to change it because I now remember I should have changed it and I didn't. So I'm really sorry about that. But it seems like, considering no one asked, probably most of you did the medium question. Right. Let's have a look at something slightly more complex. And this is again where we now start to introduce variables. This is one of the ways we can start to increase the complexity of number sequence or number series questions by adding in variables. So we've got x, 4x plus 5, 10x minus 5 are the first three terms of an arithmetic sequence. Determine the value of x and hence the sequence. Now, before we get stuck into it, I just want to highlight something here. When we say and hence the sequence or and determine the sequence, I'm not asking for a general term. I'm quite literally asking you to just give me the terms in your sequence. That's it. If I want the general term, I'll either ask it as determine the general term, determine the nth term, the formula, something like that. But if I say find the sequence, I just want the list of numbers. Okay. So if we have a look at an example like this, it's actually quite similar to what we spoke about on Monday with the quadratics, but we're still going to approach any number sequence question that we have in the same way. What we want to do is we want to work out our differences. And to do that, remember, whoopsie daisies, we are taking term 2 minus term 1, term 3 minus term 2, term 4 minus term 3, etc., etc. So this first difference over here would be term 2, which is 4x minus 5, minus term 1, which is x. This next difference would be term 3, which is 10x minus 5, minus 4x plus 1, which is plus 5, which is term 2. Now, guys, remember, I put in brackets, or we should put in brackets, because we would need to distribute that negative 1 into the brackets. If we don't do that, we're obviously going to end up with the wrong answer. So we need to remember our brackets, or at least we need to remember to distribute in the negative. Now, that's all well and good. I've done all of this, but can anyone tell me why I've worked out the first differences? Why is knowing these expressions potentially quite useful for me in order to work out x? What do we know about the first differences? Nice, Kakliko. The first differences are constant. They're the same. So what you've actually done here is you've allowed yourself to set up an equation, and Morgan's actually put it there in sort of like an algebraic format. We know that the difference between term 1 and term 2 is equal to the difference between term 3 and term 2. And that's a really, really important concept to know when it comes to arithmetic or linear sequences. So we're going to use that fact in order to work out what x is. Now, guys, obviously, if you want to simplify this as you set up, go for it. So 4x minus the x is 3x minus 5 on the left. 10x, remember, you distribute the negative, so 10x minus 4x is 6x. And then again, we're distributing that negative 1 to the 5, so it would be minus 5, which is negative 10. And now that we've got an equation set up, we can solve. They're linear equations because it's a linear pattern. How you guys choose to do this is up to you. Whether you put x's on the left or the right, it really doesn't matter. As long as all your signs are correct, whatever floats your boat. So I am going to actually put my constants all on the left-hand side. So that means I would have minus 5 plus 10, and then 6x minus 3x. Again, guys, you don't have to write that down. If you're happy to go straight to 5 equals 3x, that is absolutely fine. Alrighty. It would also help if I had my signs right. I said this the other day. Signs is always where we go wrong. It's 4x plus 5. Sorry, grade 12s. Don't know how my brain is working today. So this is 15. And then if we're going to solve for x, we divide both sides by 3. And we get that x is equal to 5. So just in case you weren't following what I was doing, I was being a bit stupid. This is 4x plus 5, and I wrote down 4x minus 5. So that sign tripped me up. So just make sure you've got the signs right there. That was just me not concentrating. And we now have what x is. So that was the first part of my question. I then had to find the sequence. Now, because we know the sequence is x, 4x plus 5, 10x minus 5, we just substitute our value for x in. So we've got 5. 4 times 5 is 20, plus 5 is 25. 10 times 5 is 50, minus 5, 45. So now we've got the first 3 numerical values of my sequence. So what I want you guys to do for me quickly is work out the general term of this pattern. So I'm adding a little question here. What is the general term of my pattern? See if you can tell me. Again, you're welcome to put it in the chat. Once you've got it, if you want to let us all know and unmute yourself, that's also awesome. Nice, Morgan. So guys, again, what Morgan's put on the chat there is perfectly acceptable. Like I say, you don't need to simplify. You can if you want, but like you really don't have to. Your markers will mark it correct. So Tn is equal to A, which is 5 plus n minus 1 times your difference. You're adding 20 each time. If you do want to simplify, just so that you know, Tn is equal to 20n minus 15. So if you simplified it, that's what you would get. Very so nice. Nice. Ooh. Either one, guys. Like I say, your markers will mark both correct. I like to simplify just because that's always been drilled into me. But if you don't, you're good either way. Okay, nice. Let's take a screenshot of that one. And then I'm going to give you one to try by yourself with some variables. And then I would like to do a slightly meatier one. Okay, hope we've got our screenshots. I'm going to move. All right, so this is the you try one that I would like you to have a go of. Again, I'll give you like 5 minutes. You can have a go of it. There are 3 questions. Determine the value of P, determine the sequence, and determine the value of the 49th term. So have a go of that one. And again, guys, like I said on Monday, we often like to introduce variables into our number patterns and our number sequences. So being comfortable with these sorts of questions is really important. And again, if you've got questions, you're welcome to unmute or put them in the chat or direct message me. Either one's fine. Okay, again, I just want to check in. Do we need a bit more time? No problem. Cool, no problem. Can you tell me which question you guys are on, just so I can sort of gauge how much time you need? You see. Okay, cool. So we're about halfway through. No problem. Awesome. Okay, guys, let's have a look at what we should be getting here. So, like I've already said to you, straight like that. We are working with an arithmetic pattern. So there were a few questions coming through, and the question was around I'm getting fractions. You don't always need to panic when it's a fraction. Okay, so my advice to you is if you are getting fractions, so for example, p is a fraction, it's a half. My advice is substitute it into the formula. So work out the sequence exactly as B asks you to do, and then double check that it's arithmetic. So remember, sometimes we're a bit mean and we give you patterns that have fractions in them. There's nothing wrong with that. We just don't like fractions. But a linear pattern can have fractions. So if we go and do exactly what we did in the last example and work out P using our first differences, you do get that P as a half. When you go and substitute into your sequence, so you get term 1, term 2, term 3, you get a half, 3, 11 over 2. If you don't like 11 over 2 and you prefer 5.5, that's also absolutely fine. But what you end up seeing is that now your constant difference when we get to question C is 2.5. So you're actually adding a fraction each time. So again, if you wrote this as, sorry, as 5/2, that's also absolutely fine. It just happens here that your difference of what we're adding each time is a fraction. There's nothing wrong with that, but it does throw us off a little bit. So again, my advice, if you are a little bit worried about whether or not the fraction is correct, once you have P, find that sequence like you did in B and make sure it is linear. If it's linear, you're on the right track. Okay, so I hope that answers the questions about the fractions. Are we all good? Thumbs up, thumbs down. Nice, guys. Alrighty, so I want to do another slightly more complex one. You're going to see I'm going to skip a few examples, but that's okay. I want to have a look at example 5 here, because this is also one that I love this question. It's such a cool question. There's also like such an easy way to do it, but there's also a way more complicated way to do it. Both of them are fine. But again, it just shows you how like maths is really cool, and sometimes the ways that we think we should be doing things are not necessarily the easiest, but also not necessarily wrong. Okay, so example 5, I think this would be our example 3, says in an arithmetic sequence, term 10, so remember our notation, the value of term 10 is 34, and the value of term 4 is 10. I want you to tell me what the value of term 50 is. Okay, now like I said, there's two ways to do this. One is super, super easy if we think just about this problem logically. The second is through simultaneous equations. It doesn't matter which one you use. You're going to get the answers anyways. But it is important to know that there are different ways of answering these questions. You need to see what works for you. So the problem with this question right now is that I've got two random terms in a sequence. It's not possible for me to look at that and say, okay, cool, the difference is this. I would need to put in a bit of work in order to find my difference. So what I like to do is I like to almost set up my sequence. So I know what term 4 is. Term 4 is 10. I don't know term 5, 6, 7, 8, 9, but I know that term 10 is 34. So that's the information I have. I eventually want to find the value of term 50, but we'll deal with that just now. Okay, so what I like to do is I like to say, okay, I know what term 4 is, and I know what term 10 is. I know to get there, because this is a linear pattern, I'm just adding the same value each time until I eventually get to term 10. And because it's the same value, we go back to algebra, we go back to our like terms. If I'm saying x plus x, I have 2x. If I'm saying y plus y plus y plus y, I have 4y. If I'm adding the same thing, I can start to use my algebra knowledge to set up an equation. Because what we now know is that 10 plus 1, 2, 3, 4, 5, 6 differences will give me 34. Just a basic linear equation. And this is now easy to go and solve. 6 differences is equal to 24. And so the difference in this number pattern is 4. So all of these differences that I've said I'm adding over here is plus 4, plus 4, plus 4, etc., etc. I'm not going to write all 6 out. But that's all we're doing. Now, if we want to go and work out term 50, obviously what we need is our equation, a plus n minus 1d. So I know what my difference is. I've just worked that out. I need to know what a is, though. Now, because we know what the difference is, we can just work backwards. In order to get from term 4 to term 3, I would subtract 4. Don't know why I wrote that down there, but it's fine. We'll just roll with it, which gives me 6. I would subtract another 4, which gives me 2. Another 4, which gives me -2. So once you have that difference, that's what I was saying earlier. Once you've got that difference, there's so much you can do with it. And now that we know what our first term is, we are very easily able to work out the value of term 50. Okay, we're solving for n, which means that when we're solving for n, we're solving for t of n, or term 50. So remember, that means that my n value would have to be 50. And then you just chuck that into a calculator and you work out what your answer is. So the value of term 50 here is equal to 194. So when you are given a question like this, like I said, it's absolutely fine if you wanted to set up a simultaneous equation, which I'll show you quickly at the start of our lesson on Monday. But there is no need to overcomplicate the question. So when you get a question like this and you're not too sure how to approach it, what I like to do is I like to just set up my sequence, see what I'm working with. That's exactly what I've been saying the whole time. Look at your sequence. Can you work out a difference? Look at what you are working with. In this case, because we don't have all of our term values, what we're going to have to do is we're going to have to do a bit of work to get our difference. But I have the information that this is arithmetic. So I know that the differences are constant, which is why I was able to go and use difference plus difference plus difference plus difference in order to work out the value of D. All right, so when it comes to these types of questions, we don't need to panic about them. We just need to think clearly. And this is why I'm saying set it up and don't rush into an answer before you need to. Right, guys, does anyone have any questions? I'm just going to leave it there for you to take a screenshot. I know we're like 3 minutes early, but it's not enough time to do an entire simultaneous equation. And we've covered arithmetic. And so what we're going to move into on Monday, got to get my days right, is now looking at arithmetic series, which is different to a sequence. Because now we're starting to find the sum of values, and this is now where we are going to introduce a new formula. Right, but guys, if you've got your screenshots and if you don't have any questions, you are more than welcome to leave, and I will see you guys on Monday, and I hope you enjoy the rest of your week and your weekend, and I will see you on Monday if you don't have anything else that you need.